going to prove the following trigonometric identities, basically by getting the common denominator and using Pythagorean identities. So I'm going to work on the right side and change tan and write it in terms of sine and cosine. Alright, and then I'm going to do the common denominator, which is cosine. When I do that, I'm just going to cross these up here. So that's just going to be sine of theta minus sine of theta times, there's two cosines now. Cosine times cosine is cosine squared of theta. Alright, now we've got to get it to look like this left side. So I'm going to go ahead and factor out a sine theta here. And I'm going to get 1 minus cosine squared of theta. As you distribute back, you get the numerator. Okay. So, when I do that, 1 minus cosine squared of theta is sine squared. So you can get sine of theta over sine squared of theta over cosine. And I can rewrite this as sine of theta over cosine of theta times sine squared of theta over 1. I'm trying to match it up to that. So this equals tan. So you get tan of theta times sine squared of theta. And it matches. So, next one's very similar. You might want to try it before, pause the video and try to do it, but it's the same steps. So cotan, I'm going to go ahead and write in terms of cosine and sine. And then find the common denominator. So that's going to be 1 there. The common denominator is sine. So when you cross these two, you're going to get cosine of theta minus cosine of theta times sine squared of theta. Because you're multiplying these two and you get sine squared. I'm going to factor out a cosine of theta and get 1 minus sine squared of theta over sine theta. This right here equals cosine squared from previous videos. So we have cosine of theta times cosine squared of theta over sine. And what I'm going to do is write this as cosine of theta over sine of theta times cosine squared of theta over 1, because I'm trying to match it to this left side, or right side. And this is going to equal cotan of theta times cosine squared of theta. And it matches. So we have proved the identity. Thank you and have a nice day. Bye-bye.